Is it going well?
Yeah.
You're making good progress? Okay.
Wait, did I miss? Did I miss something?
No.
We don't need long cosine.
Oh, you do. Okay, so example 18, how's that law of sines working out?
Not working.
It's not working, right? It's a problem because you probably have two variables in your equation if you're trying to do the law of sines. So in this case, notice, and does it make sense that the triangle that you've been given is SAS?
Yeah.
When you have SAS, you cannot use the law of sines, it just doesn't work. Instead, we have to use a different law. The law of cosines. So there's there isn't a lot of room to present this up here. For some reason, there's just no space for law of cosines. It goes directly into an example. So I'm going to make some space. I'm going to divide this, and we're going to, oh, it's frozen, excuse me. And divide that. I suggest that you do too. I'm going to write notes to the right and write them very small. Then we'll do example 17 a little bit later to the left of that partition. Now you remember law of sines, it was built on stuff you already knew. Do you remember how we derived the formula for law of sines? Well, even before cross multiplication, we had a not a right triangle, but a oblique triangle. And we made the altitude and then two expressions for the height. Remember that? It's kind of cool how the formula just came together. Same thing's going to happen with law of cosines. The setup is different, of course, since it's a different formula. I'm going to make a coordinate plane here. No, it is on the left. I'm going to want to write a bunch on the right. So I recommend that you kind of keep it smallish. I'll make a triangle here with one of the vertices at the origin. Maybe like this. Yeah, that looks good. This is A, B, and C, which means angle A is down here, angle C is here, and angle B, you know where angle B is. I will once again drop an altitude. In this case, since I put it on a coordinate plane, what I am going to do is make some coordinates. Like the coordinates at that point up there. Any idea what the coordinates for that point might be? The one at the top of the altitude? Well, let's mark, I'm going to mark this side of the triangle here, X and Y. So I need an expression for X. I want this to be in terms of A, B, and C though. So for C. Oh, I'm hearing it. I'm hearing sine of C is equal to Y over A. So I think that give us a Y value, right? Y is equal to A sine of C. If I want the X value, it'd be A cosine. Do we agree that X is equal to A cosine of C?
Yeah.
Are we good with that? I'm just putting some little notes in the triangle up on the side here, but I do want you to be able to, in a right triangle, adjacent is equal to the hypotenuse times cosine, and opposite is equal to hypotenuse times sine. So that's why the coordinates of that point up there are a cosine C, comma, a sine C. Yeah. Okay, we know that the coordinates at the origin, of course, are 0, 0. Do you know the coordinates of the last point? Please don't call it out, but discuss with your neighbor in terms of A, B, and C. What are the coordinates of that point at angle A, B? We know that the y coordinate is 0, and the x coordinate, do we know what it is? It's exactly B. Is that clear? Next, and this is really cool that someone just kind of analyzed it such that we could put all this information together. Take a look at, there are 3 triangles. I want to look at the one on the right, not the big one, not the one on the left, but the one on the right. And let's make an expression that comes from the Pythagorean theorem there for that triangle on the right. We'll start with c squared equals, well, I want it to be all in terms of A, B, and C. So let's see, I'm going to start with the bottom. Like the bottom is, what is this length right here? B minus A cosine C. Are we good? Are we good with that? That's that bottom length, and of course I have to square that. And the other leg is A sine C. And let me erase some of my side work here because it's getting in the way. A sine of C squared. Okay. Great. What should I do next? Distribute, or let's expand the binomial. Now let's square the stuff. C squared is C squared. B minus A cosine C squared. I'm going to do it silently while you do it on paper. Once you've expanded it, check with your neighbor, make sure that they did it correctly. So it looks like this. And discuss how we could simplify that. You should see something really nice. Something very comfortable. You see it? You see the loveliness? I want you to simplify it. One more, so I want you to find something to simplify it. To be very comfortably simplifiable once you see it.
Satisfying, depends how it has
What do you see?
I'm just gonna take a while to get to the cosine squared C and the sine squared C, so get out of it. Actually, no.
Don't take it back. Take back to taking it back.
Well, I was gonna say, just cosine. I was gonna say cosine squared plus sine, squared of theta is normally 1, so
Yeah.
we just simplify it. But
So you can smell it, right?
Yeah.
Smell it.
So I would say you could say it's 2a squared.
Well, what we have to do is take these terms and what do we do? Factor out A squared, so we can get what we want. Right, it's there. You just have to take it. So C squared equals B squared minus 2AB cosine C plus, and I'll factor that out, cosine squared C. So Ben, you're right there. You saw exactly what I was looking for. And now we can see how to simplify that. And I'm sorry that this is so small. Pull that up here. That's just 1 there. So B squared minus 2AB cosine C plus A squared times 1. I'm going to rewrite this so it's a little bit cleaner. Namely, C squared equals A squared plus B squared minus 2AB cosine of C. Ladies and gentlemen, I present to you 1/3 of the law of cosine. What? Yeah, that's a lot. Ben, if I could just capture your face right now. That's 1/3 of, wait, what? Yeah, there are two more equations. So imagine that's like getting to Disneyland and find out there's another Disneyland behind the Disneyland. Right? It's kind of the same thing. And there are no lines that ain't Disneyland. Line. Never. Okay, the other one we're gonna say is b squared is equal to. Now it's not the same equation. I'm gonna change things up. The second equation, I'm not gonna derive it. I'm just gonna ask you to take a leap of faith that it's going to be b squared is equal to a squared plus c squared minus 2ac times cosine of, how do you know it's b? It matches the first. So maybe you could do the third one already. Maybe you could already write it down. Yes, you have a question?
Aren't they all the same, just whichever angles you put in there, you can see?
Exactly. It's not really that, but there are 3 different ones. It's just, it can be expressed 3 different ways for the same thing.
Really, it's all.
It is all exactly the same. You're right. There's just one Disneyland. It's just you could go on through the side,
Or the other.
get the other side. They all have lines. They all have rides. They all have funnel cakes. I think. Okay, the last one will be told to us from the one and only Aaron. I know it's not as intuitive as sine, like to memorize it. Law of sines, I hope you agree, is just a beautifully elegant formula. This one, we could use it. And we use it when we get to a particular kind of triangle, namely SAS. Here we go. The angle that's being referenced is angle A, 115 degrees. So the version we're going to start with, the version we're going to use begins with a squared equals b squared plus c squared minus 2bc cosine of a. I'll let you finish this. Please solve the entire triangle. Sound like you've forgotten what the cosine of 115 is.
Yeah, okay. Or the type of good tomorrow.
Thursday. And next time, it's a Friday, like, where's that? That word problem. Dreaming about it.
What,
Man,
like, how much do we round to which foot?
for side lengths, the 3 hours.
Oh,
Meetings.
yeah, you just go up there and it on.
Yeah. Thank you, Julian. Good tip.
You find that? I know you. Oh, no.
What are they going to do for it?
Wait, I'll make
And then the rest is. Yeah.
What else? What plus or minus?
Did you get it? You're done with the triangle, the whole triangle? I want all.
We have a three, no. Two sides of the triangle, I want two angles that side. You decide on the best value. Yeah. Here's the second. So what's one thing plus or minus? I want to.
Yeah. And then it's coming.
You about ready to be called on?
Like in the next hour. And it was already, it was hard to refer to the other platforms. Another type of.
Okay, are we ready? Give me 15 seconds. Okay. I'd like to hear from Sabrina. Did you solve for A?
Yeah.
Okay, what'd you get? $1.255. Did anyone else get that? Okay, nicely done. With that, would you like to continue? So use law of science to get that, or how do you get? Cool, and tell me one more time, what did you get? 25.2, and these are both degrees. Did anyone else get that? I imagine if you got the other ones, you got that. Thank you. Also, here's the point. This is great. You don't have to retype it. Get that number by doing one. Great, thanks. Right. Are we good? Cool. Okay. Yeah, that'll be a time saver, huh? Oh, man. Let's continue down here. 421. So SSS, again, if you try to use law of sines, and there's no angle here, you're gonna have two problems. We're gonna be using law of cosines, and I'm gonna tell you exactly which one to find first. When given a choice, find the largest angle first. Is that right?
Yeah.
Okay. Find B first. Angle B. And I'll talk about that after we finish the calculation.
And you have to find the one that has a sign that. No, I'm supposed to be, yeah, that's how yeah.
Trying to make sure that your neighbor's on the right track with that first equation. For the biggest angle. Okay, are we ready to talk about this? Okay, so. Look at all this language. Before you calculate this, of course, in your calculator, you can use cosine inverse. Before you press it, no one thing is going to be true about the same.
They more than that. I don't know. It's next. Let's go for the second. Second one. Negative the second. Third clause, I was worried that the factor might give us a third one. It's not a domain, so we know that the factor. And this gives
us, let me check what happened here. Natalie, what did you get for B? 116.8. Do we agree with Natalie?
Yeah.
Okay, Natalie, you did such a good job. I'd like you to continue. Where do we go from there?
Over next to. Is equal to sign over 14. And then. I just multiplied it by. Which.
You can skip the details. It's
Is equal to 41.1.
41.1. Did anyone else get that?
Yeah.
Okay, and then?
And I did 41.1 plus 163.8.
Okay,
That added, I got 22, and then 180 minus that.
okay.
That was 22.8.
22.08, so 22.1. Okay, are we good with these? Nicely done.
in terms of rounding. Like one of here, if it might work, it might not.
Well, I, for the sake of writing, I give it my practice.
I'm not going to make certain of that. Yeah, but you never have to write out the entire. Register. So there's beautiful done. Any questions about this process? Okay, so Henry, you have some great questions about why we do big input. Let's say we didn't do the big input. We didn't do the big one, and the answer here would definitely be an acute angle, which really was an obtuse, still hiding from here. And if we find an acute angle from here, it's going to be an obtuse triangle in there. So we're looking for an obtuse triangle using the law of sine. What's the problem with it? It's an obtuse angle if you're using the law of sine.
Well, it's not gonna be one of them, that's right. But I think it's really different. So,
Yeah, your calculator, when you use inverse sine, will always give you
good.
an acute angle. Let's just say you got to something
Like, let's say you got to something like sine of A equals 0.3. Right, that could be either here or here.
Yeah, the calculator always gives you the acute one, so you could, as long as you're careful, it's gonna work out. You make sure that opposite from the big angle, big side is a big angle. So you wouldn't be given an acute answer. You have to do evidence version, like away from each angle. Yes.
If you already started with doing that one,
Mhm.
we did.
Yeah. Exactly, you'll be fine. So it's just to prevent mistakes, really. Yeah, so my recommendation, always start with a big angle when given a choice. Now, if that big angle would have been acute, is that possible? If the biggest angle could be acute?
Yeah.
Yeah, but nothing's lost. The process is still the same. You definitely won't make a mistake on the other two acute angles. So start with the big one. Now, if you don't, you can still get it right. It's just less likely. And I want you all to get 100%. I do. At least close to it. Can you make my dream come true? Probably not.
Oh.
That's a challenge.
One second, we didn't do that.
I'd probably not.
So,
Yeah. Yeah, it's a tall order. And for people who get the 100%, yeah, I bow down. Here's a great question. Hey, please don't call out the answer. Once you have an answer for this, discuss quietly with your neighbor. Example 22. Discuss quietly with your neighbor once you have an answer. Okay, did you finish the problem?
Yeah.
Takes a lot of work, doesn't it?
Yeah.
How do you do this?
They were, when they added together, they were small.
Yeah, this is not a triangle. And did you use law of sines to figure, or law of cosines to figure that out?
No.
Hopefully not. You know this is not a triangle because, nice. Well, the sum of any two sides has to be greater than the third side. Maybe the hypotenuse, but it could be any side. Do you know another way to say that? Like mathematically, sum of any two sides is greater than the third side of the triangle. What's that? Oh, triangle inequality. That is what it's called specifically. Maybe it's still using math, but what I like to think about it is that the shortest distance between 2 points is a straight line, isn't it? I think people, even if you're not mathematically inclined, you know this. The shortest distance between 2 points is a straight line. Do you see how this breaks that rule?
From A to C, this should be when there's a button. And also according to this is a shortcut. Impossible. Yeah, it's impossible. The sum of any two sides must be
Longer than the third side. So don't waste time if you see this on the quiz next time or the test in a couple weeks. Just say, oh, it's not a triangle. Move on to the next one. And smile to yourself, of course. Yeah. Oh, definitely put reasoning. Like you could say something like, too big. Something like that. That would be perfect reasoning. Moving on, I want to go up to, oh, let's go back to example 17. What happens in the law of cosines when the angle referenced is a right triangle? Okay, I think it means to say right angle. So let's say this is A, B, and C. Would you please write the law of cosines involving angle C here for this right triangle? Yeah, for angle C. So starting with what? We're talking about angle C, that means we begin with A squared equals A squared plus B squared minus 2AB times cosine of 90 degrees, which is angle C.
Right.
Right, literally.
Wait.
That's a good one, Ben. Cos- Is it? So cosine of 90, we know cosine of 90 is 0. That's why this whole thing goes away. Two AB times 0 is
Wow.
So this whole time you've been using the law of cosines. Did you know?
There's no,
What's that?
there's no way this was found, this was discovered before.
There's no way. Absolutely not discovered before Pythagorean theorem. What's interesting, this Pythagorean theorem is just a special case of law of cosine. Pythagorean theorem, for sure. I don't know. I mean, it was used to, we used Pythagorean theorem to derive law of cosine. So that one had to come first, but they're definitely intricately connected. So, but remember, when it's a right triangle, don't use law of sines. Instead of law of sines, use SOHCAHTOA. Right? If it's a right triangle, use SOHCAHTOA. if it's a right triangle, instead of law of cosine, use just Pythagorean theorem. Don't waste your time with a minus 2ab cosine of 90. What's the point? That's the whole term anyway. If it's a right triangle, it doesn't matter. Okay, oh, I want to talk a little bit about mental math before I give you one last problem. 19 squared. Do you memorize what 19 squared is? You memorize it?
Yeah.
Nice.
I feel like I don't know why.
No, I actually do. I know most of my students.
Up to what?
I mean, I know like random ones.
Okay.
You know, it's like.
You know, like 300 squared.
289.
Oh, I'm convinced. He knows, if he knows 17 squared, 289, I am good.
Hold on.
Yeah, 15, yeah.
11. I don't know that one. I don't know.
916 squared. If I have some time, I'll show you a little trick with squares at some point. I do want to show you a little bit of mental math. I'll show you two little tricks here that I use, like this one right here, 2 times 8 times 14. I'd like you to avoid calculators if you can. Calculators are great, but don't forget that your brain is a muscle that needs to be exercised from time to time, even with arithmetic. So how can we do this in our heads? Fairly simply. What's that? So 160.
Oh, I did.
Oh.
80 times 20.
Oh, so you're doing 16 times. So you're doing it like this, kind of breaking this up.
Oh, I did it 80 times.
Oh, 8 times. Oh, 8 times 28. 28. So maybe you did something like this.
Yeah, I did that.
Does anyone else do it like this? Like you kind of make a distributive property problem. It's a great way to do it. Yes.
I was like, I was about to know the elements of that.
Uh-huh.
You know, 15 times 14. Can you like make that into 16 times 15?
No.
Well, that's actually where I want to go. That's, Elika, that's exactly where I'm headed. These are great ways to do it, but I do want to talk about, this is a special case, 14 times 16. It's not 15 times 15, but it is 15 minus 1 and 15 plus 1. Isn't that 14 times 16?
Oh, and then that.
And now this is just 15 squared minus 1, 225 minus 1. It's really nice.
Wait, this, oh, what is this?
Yeah.
I don't actually.
You said 15 times 15. That is not cheap.
So, I mean, what's nice about this is if you get a special case, if it's like 68 times 72, you see that you could actually now do this in your head?
Yeah. 7 squared minus 4.
Oh, mine is 4. No, mine is 4.
No, minus 4. It's the one that isn't 49 minus.
Well, this is 70 minus 2 times 70 plus 2, right? So it's like 4,900 minus 4. I think you could do that in your head. 4896.
Wait, no.
Yeah.
Only works next slide. 485 to 75.
It works for everything. And you can,
Yeah, that's what I mean.
if you want to do 27 times 20 times 31, you could do like, oh, this is 29 plus 2. But I just don't know how helpful this is.
You know, wait. It's better to say, one, it's not that helpful. Yeah, it's not helpful.
It always works, but sometimes it's more helpful than others. Like this, like this is true. Let's look from that where it says that. And we know this function squared. You know what 49 squared? 49 squared is
41.
No, it's not.
841. Oh my god, 841.
I knew it. I knew it.
Like, so like,
I did it. When one, or like 98 times 102.
98 times 102. Oh, yeah.
Be like 9,000.
Right.
41. I am right, you're wrong.
Ben, that's really impressive.
Ah.
It is, right? It's so nice. So lastly, I want to talk about, and unless you're Ben, you may want to find a different way to do this. I agree that this is not as pretty as the one that I just did. And I hope that you appreciate that difference of squares. If you like that,
Yeah.
I hope you like it. 19 squared, one way to do this would be to, do 20 minus 1 squared. And now 400 minus 40 plus 1. And there's a 361. So that 39 squared, that's right.
9 squared is 1521.
I don't know, let's see, that's 40 minus 1 squared, so 1600 minus 80 plus 1. Yeah, you got it.
45.
Yeah,
What about 20?
it is, nice.
I know random ones, it's kind of fun. That's why I like it.
I feel like I need to bow down to Ben. That's incredible. He is. Any questions? Any questions? Perhaps your question is, can we have one more?
No, yeah, sure.
Okay, it's not math sense. It's not a math sense one. It's where is it? Oh, up here. Excuse me.
Yeah.
Oh, look at this one. Example 20.
I don't like this one. I still don't know the plan. Wait, and I found out, oh my God. What is this? I know, I think. I appreciate that. After you're drawing a diagram, please make sure your neighbor has the same diagram as you do. And if they're having a hard time, give them a chance.
Would someone like to put the diagram up on the board?
I don't, okay. Good morning. I don't. Six no. This one's 16. Oh, they're going different directions. No, I'm really okay. Oh, yes, oh, that's not the answer.
Yeah.
So one is going west and the other one is going west and south. Like this way. Oh. I think it's okay. The one in the bottom is one. No,
Does someone want to put the diagram and the word on the board?
The person on the side.
What is it? Exponential and logarithm.
I love it. No, that's great. Oh, yeah. I don't think there's much to do. Yeah, I was only thinking that. Oh, I know. That doesn't look. I may have gone there. I was. No, but the first I said. All three of them. I know, I just know. Yeah. But the midterm, you know, the places are very.
No. They're just that last. But it
Perfect.
Are we going to the diagram? Yeah. Hey, good idea. As long as these are in the right place. Good. Perfect. Once you get here, maybe that, the rest of that. Right, this is a little bit of the morning. What happens to simplify the calculations here? You know, it goes back about. That's not gonna think about that one. Right hand side. When 36 or 48, that's 36. That's 41, 49. It's stupid. Well.
You can literally write it out.
That's so long.
I don't read in a picture. It's like.
It's trying. How do you simplify it?
Divide all by 12. Dividing all by 12.
Let's divide all by 12. I think we have a smaller triangle. Like about by 12, I have 3, and I have 4, 3. And this is still 60 degrees.
5.
No. That wasn't funny.
Does it make sense that you could use this one because these triangles are similar? Yeah. Just you have, once you find the answer here, and then multiply by 12, you get that. What is the answer? 41.
Yeah.
So if you didn't hear it, I do not like all the. 3.1 times.
Because that's one way to simplify your life, right? Work with smaller numbers until you can. If you can simplify it.
3.6.
3.6.
Okay. So it's like multiply by 7.
Before I give you time to work on on the assignment. I want you to see if you could think about this. You know, like. Five, minus one. I can remember what we did today. Five, like, yeah.
Oh, so it's five, where the minus one.
Five square minus one.
Oh, so 24.
Yeah, and maybe you wanna do it, it's super weird, it's obviously not funny, but you can do this.
121 minus 1.
What you already know.
Okay. Oh, you have 21 minutes to work on your assignment. 21 minutes. Look at that, happy to do work, I love it.
Actually,